Today we're going to find critical numbers from the first derivative. We're not going to do anything with them. All right. We'll be doing stuff with them down the road. This is going to be a key to graphing functions. All right. So critical numbers will be x values where things might happen. More than just, like, imagine if you got some graph that's going like this. And let's say I found this x value. That's cool and all, but it's nothing really important's happening there. And this one also is pretty cool, and that one's pretty cool. This one's coolest because it's the lowest point of the graph. And this one's coolest because it's the highest point of the graph in that area, right? So what critical numbers for the first derivative do is they tell us if the first derivative is 0, and the first derivative represents the slope of the tangent line, and we look at the tangent line at this dot right here. Notice the tangent line at the highest point is horizontal, and the tangent line at the lowest point is also horizontal. So if the first derivative equals 0, we might hit a low point or a high point. Okay, so critical numbers, x values where things might happen of importance to us. Other things that are important to us, f prime of x is undefined. Okay? If the derivative is undefined, different things could happen. Here's one reason that the first derivative can be undefined. There's a sharp turn like that. There's no derivative. All right? So that's a situation where it could hit a low point, but there's an undefined derivative. All right? So places where the derivative itself is undefined. Also, let's suppose we have some kind of square root function. Okay, it's undefined there because, again, granted I could probably find some slope there, but there's hundreds of lines that cross through there at one point. So an undefined derivative, or the endpoint of an interval. We saw yesterday with graphing that the endpoint of an interval, let's say we're graphing from here to here and we stop, that's a local maximum, this is a local minimum, right? Because it's the highest point in its area, the lowest point in its area. So endpoints of intervals are automatically critical numbers. So what we're going to be doing here with finding critical numbers is we're going to compile a list of x values that we're going to want to put in our calculator to evaluate for the function to get points. They're not going to find me these points, they're going to find me top points and bottom points. All right? And then second derivative critical numbers, again, down the road, is going to be something we're going to focus on to find other things of interest. All right, so take a look at example 4. Find the critical numbers of f of t equals this. Okay, so there's just a little checklist here for critical numbers. Set it equal to 0, find out if it's undefined, if it's the endpoint of an interval. That's your checklist. So when I make my list of critical numbers, x equals these numbers, they fit these 3 criteria. So basically this is just the checklist. You do the derivative, that deals with steps 1 and 2, and then if there's an interval, then those numbers count automatically. So, is there an interval? Does it say from something to something? No. So as far as you got interval 1 or checklist 1, 2, 3, if there's no interval, there's no critical numbers because of an interval. Okay, so that's pretty simple. The other 2 come from the first derivative. So as soon as I see a function and it says find the critical numbers, that's my directions, I'm going to do the first derivative. So this is just a polynomial function, so it's going to be 9t squared. It's going to be plus 14t. It's going to be minus 12. Okay, the first thing I look for is when does that thing equal 0? All right, so when does 9t squared plus 14t minus 12 equal 0? How in the world am I finding that out? Don't anybody speak at once. Quadratic formula. It's a quadratic equation set equal to 0. So we just get our calculator out and I type in program quad, hit enter, 9, 14, negative 12. And my calculator tells me at 0.6144 and negative 2.1699960. So 0.6144 and negative 2.1700. Rounded to 4 decimal places there. All right, those 2 values, things will happen. Okay, it'll hit a high point, a low point, maybe. Another reason the slope could be 0 is maybe the graph comes up like this, flattens out, then goes like that. That's a slope of 0 also. Doesn't necessarily at high or low point add a critical number. It just gives us the possibility something might happen to those 2 points. So let's investigate those further. All right? When is 9t squared plus 14t minus 12 undefined? Because that's criteria too, right? Undefined. When does this function, when is that undefined? When can you not square a number or multiply a number times 9 or multiply by 14 or add or subtract numbers? Is there any number out there you can think of you can't square or multiply by 9 or 14 or subtract 12 from it? I can't either. Polynomial functions don't have undefined points. So if you have a polynomial function to begin with, this isn't going to happen. If there's no interval, this isn't going to happen. The top one's the one that happens the most often. Okay? And the problem the Calculus 1 students have is that these happen so seldom that eventually we get to a point where we just do number 1, forget about 2 and 3, and eventually they throw one at you that has a 2 or 3 in it. So be diligent that you look at all 3 criteria every time. These are almost always empty sets. Sometimes they aren't. And when they aren't, you need to deal with those. So just looking at this specifically, let's go back here to my calculator. Again, that's all they want, critical numbers found. There's my list. All right. But again, where we're going with this is we're going to be graphing. And this is going to be one of the things we need to do before we graph. We need to find values of the variable that will be of importance to us. If I were to type in this equation up here, f of t, which is 3, I'm going to go x cubed plus 7x squared minus 12x plus 4. And I'm just going to set a window from -3 up to 1. And as far as min and max for y, let's go -20 to 20 so it happens. Maybe we can see. Thinking that we won't. Nope, there's. All right. Obviously, the low point there, we don't see the high point there, so let's just go back to my window. I'm going to go from -2. That seemed low enough. Let's go up to 40. See what happens. Let's see the top. Perfect. Okay. There's a high point over there. There's a low point over there, right? So there's our graph. And what I'm telling you is that this x value is the x value of that point. All right. And if I go calc maximum, left bound, I'm going to go -3, right bound -2, and guess, as long as it's between -2 and -3, it's fine. I'm going to guess -2.169998546. Just write that out. What a good guess. All right. -2.1699994. Right. That's exactly the point that we found. Right. The slope is 0 at that point. All right. X is that. Y is 32.347361. Y is not a critical number. X is the critical number. Y is the value of the function at that critical number. All right. So again, when it says find critical numbers, you're finding values of X where important things happen. Okay. If I go back here and calculate the minimum, because that looks like a minimum, right? Let's go 0 left, 1 right, and let's go 0.6144 for a guess. And it's 0.614444. Blah blah blah. All right. At -0.034638. All right. That x value results in a minimum value. So again, if I'm going about graphing this thing, and I have the ability to know that -2.17, comma 32, whatever it was, and 0.6144, comma -0.038, whatever it was, right? If I know those are 2 points, and I graph those 2 points, and I know that's a maximum, because we're going to find out ways to find out that's a maximum. We know this one here is a minimum. We get a little bit more information. I know it's a cubic function, so it gets 2 terms. All right. I can very easily, just based on that information, kind of get a basic idea what the graph looks like, just because of those 2 points. Knowing that's the highest point in this area, that's the lowest point in this area. That's where we're going with this. Okay. This is going to be a technique. This is going to be something you want to do when it says graph. So when we get to chapter 4.6, we're going to have compiled a whole bunch of techniques to find out important values. We're going to use all those together at once in order to do everything we're going to do. Okay? In each chapter we do this in, we're going to get practice in the skill. But chapter 4.6 takes everything you've learned, sticks it into one big unit, and you're going to have to graph these functions. So instead of having to find hundreds of points here to find exactly where that is and that is, I immediately found the 2 points I really care about. Second derivative is going to find me a point around here, is going to tell me something else is important. I have the ability to punch numbers in my calculator to get a few more points just to get a little bit more clarity about what the graph looks like. But the main idea here is we want to graph very elaborate graphs with as few points as possible. That's what our goal is.